Alright, welcome back to another Python programming tutorial, and today we are going to be talking about sets. Sets are one of the most important collections inside of Python and are used a ton. And, I did get my degree in math, so I kind of personally relate to sets because I did a lot of set stuff in mathematics. And this is a really, really good example of how you can apply math to the real world in a computer science programming way. So let's go ahead and talk about what a set is. A set is a collection inside of Python. It is unordered. Um, it's immutable in the fact that you can't update the specific things without doing a little bit of work. So like you can't index anything, so you can't update things in the specific way that you may have seen. And then of course it has no indices. And then a very, very, very important characteristic of sets that make them different than lists, arrays, and tuples is that you cannot have duplicate data inside of sets. And if you try and have duplicate data, Python will remove that datum from the set. And that's what makes sets very awesome actually to use in my opinion. It really, really, really helps with sets and actually creates some very unique methods that you can perform with sets. So let's go ahead and look at a very basic example of a set. So I'm going to go ahead and create a set1 variable here, and I'm going to set that equal to some braces here, and then this is an example of a set. So again, it's just like any other collection, however it has these two braces here. You can also construct a set like this with the keyword set, two parentheses, and then inside that two parentheses put the same datum that you had in your first set in this one, and these will be the exact same. So let's go ahead and print set1 and set2. And as you'll see here, when I run this, it's going to go ahead and print 1, 2, 3, and there it is. So there you go. And as you can see, there was no inherent order in how it printed it. It printed 1, 3, 2 both times because again, sets are unordered, right? Now what makes them specifically unordered is you also cannot index the various elements. So let me go ahead and show you what I mean. If I tried to type in indices 0 here for this first index, it will not work, or here either, because that's not how Python works. You will get an error here and it will say that's not a thing. You can do it to a set, as you can see. So there's no indexing anything, and sets are also unordered as well. So that's just the basic implementation of a set. You can also have an empty set, which looks like this. And if I run it, I get a nice little empty set here, which looks like this. Now, an important note to make here, it's not super important, but if you had two braces here with nothing in it, this would actually be an empty dictionary and not an empty set. Somewhat of an important note there to make, because, if you were like trying to figure out what datum this is, you would see that that's a dic. And I'll go ahead and do the type here. You can see. And as you can see, it thinks that the first set here is a dictionary and the second set here is a class. As well as set, you can also do the nice word of type, which tells you the specific collection data structure that you're working with, or the specific datum that that variable holds. So nice little key notes here is that this is an empty dictionary versus this is an empty set, and then you can use the type word. You can also use the length word as well. So if I have two elements here, and let's say I have three elements here, you can also use len to get the length of each of these individual data structures here. So this will tell you the length of both here. Here I have 2, here I have 3, and this needs to be surrounded by 2 parentheses. So 2 in this one, 3 in this one. Now, again, going back to what makes sets very, very different than other data structures is that you can't have any duplicate elements. And that's something super important to keep in mind in sets. So if I try and put a 1 in here, for example, like a string 1, print another string 1 here. And I'm going to go ahead and I'll print not the length, just the set and what's contained inside of it, so you can see here. You'll see that this 1 will be removed in both sets. And as you can see, it was removed. And again, that's something very important about sets. It can have no duplicate data. Very, very important. No duplicate data in sets. So, yep. Now, moving right along here, you can also do your very standard for loop in sets. So for example, num in set 1, colon, I can now print num. Very standard for loop where it's going to print each individual datum contained inside of the set. And so I'll get 1 and 2, and then obviously it won't print 1 because it removes that from the set because it's a duplicate. So I'll go ahead and run that, and as you see, I get 1 and 2. I'm going to go ahead and delete this now because we don't need it anymore, but this is an example of how you can use the for loop in a set. Now, sets can be both homogeneous and heterogeneous data structures. So, for example, they can include datum that's different, like so, and then it can also include data that's all the same. So these are both fine. This is obviously heterogeneous because it has an int, a char, and a boolean, and then this has all chars or strings depending on whether you want to add some more characters or not. So there you go, just the bare bones basics there of a set. Now, something very important to keep in mind about sets is that oftentimes they are called immutable, but it's with quotations or like an asterisk because they're not truly immutable. Remember, immutable means that you can't change anything about the set, right? And the mutable means that you can. Sets are immutable in the idea that once you add datum to the set, you have to change the data type of set to access the individual elements contained inside the set. So let's go ahead and look at what that means. That sounded like a whole bunch of jargon. So for example, if I wanted to change the set here, I would have to go ahead and create like a list 1 here, and I would have to do list, and then I would have to change the set into a list, and then I would do like list 1 indices 0 is equal to now 5, and then I would do set 1 is equal to set, and then I'll do list 1, and I think that should work, and then I would print set 1. So in this case, I had to typecast set to a list, then I could change the individual element that was located at the 0th index, then I would have to retypecast it back to a set, and then I would print set. And as you can see, that updated the value there, right? But this is not always the case. You can't change things without doing it this way. So it's not immutable in the fact that you can just come here and go set 1, 0 equals 5, for example. This will not work. I cannot index these individual elements and I cannot update them, right? So this will error. So in order to get around that, you would have to do the typecasting that I showed a second ago. However, you can add and remove elements, and that is something that you can do to a set that makes it different, or not exactly immutable. Is that you can't necessarily update the specific ones, like update the specific things, but you can add specific things to the set. So one way you would do that is you just type in set 1, and you do the keyword add, and then here it's going to ask for the element, and then I can put 10 here, and then I'll go ahead and print set 1. And as you see, it printed everything here. We'll get rid of this for now. We'll talk about that later. But as you see, it added 10 to the set. And in no general order, because again, sets are unordered. You can also use the update method as well. Excuse me. The updates S1. So let's say you have a set 1 and a set 2, and let's say you have set 2 equal to, I don't know, some integers. right? When you use the update method, you can take set1 and do update and then change it to a different set, like so. So this is an example of the update method, so I'll go ahead and print set1 here, update it, and then reprint it. And as you can see, it changed from here to this, right? And that's an example of how you can change up the sets. And obviously you can iterate over the various elements in the sets as well and add variables and remove stuff. You can also do the remove method if you want to remove specific elements inside the set. So let's say I have 1, the thing there 2, and then I have 20, and I want to remove the 20. I would type in set1, which is the variable name for the set, and I would do the keyword remove, and I would put 2 brackets here, and then I would do the element I would like to remove from the set. Let's go ahead and print the set before and after so we can see here. So set1, come here, remove, print, set1 again, and you'll see I'll get 2 different values here. I'll have 20 in and then 20 not in. So that is the example of the remove method. And then another nice little thing here you can do is you can also do the discard method as well. So go ahead and do discard. And as you see, it pretty much does the same thing. Now, the thing that makes discard nice is that let's say I try and remove an element that's not in the set. Let's say I try and remove 40, for example. Right? 40 right now currently is not in the set. So when you do that for the discard method, you'll see that you don't get an error. But if you do that for the remove method, it throws you an error because obviously 40 is not in the data. So that's one thing that allows the discard method to be a little bit more preferred, is that you won't get an error. So that's generally what I like to use. However, there is also nothing wrong with the remove method, and sometimes maybe for debugging you may want to use the remove method. Now the next one we're going to look at is pop. So pop's not going to remove a specific element per se, it's just going to remove the last one that it considers to be inside the set. So let's go ahead and look here. I'm going to go ahead and print, let's say I'll just go ahead and show you guys. So we'll print set1 and we'll let set2 equal set1 popped, and then I'll go ahead and print set2 for you all. And as you can see, we have now here set1, and then it removed an element and put that as set2, so it removed this element right here and put that as set2, and then it printed that value. And that's what pop does. It essentially removes the last item from the set, and then you can assign that to a variable like so. And this is a good another example of how you can use that. So another thing you can do is you can also use the clear method. So the clear method is going to take a set and clear it, as you can imagine, which will of course delete all the values inside the set. So I'll go ahead and show you guys what that looks like right now. So as you see, you have this, and then you have none because I cleared it, so now I get the value of non-existence, right? Now you can also use the keyword delete or del, which will completely delete the set. So I can go del, which deletes the set, and then I can go set1, and as you'll see here, it doesn't even register that set1's there anymore. It's like confused. It's like, I don't know what's going on, right? You just deleted it. So if I print set1 here, and then let's say I tried to access a value from set1, I get an error because the set1 was completely deleted from memory. So there you go, guys. There's some nice little keywords and some methods you can perform with sets. Now, where sets get really, really interesting comes with the fact that they were, again, unordered, but they also could not have any duplicate elements. And this gets to how you would join sets together. So I'm going to go ahead and pull up a nice little paint diagram here so you guys can kind of follow along as I go through the various set join operations. So the very first one that you might be useful or used to is going to be the union operation. So let's go ahead and look at that one. Let's say I have 1, let's say I have 2, let's say I have 3 here, and then let's say I have sets 2 here. Let's say I have this, and then I have 10, 20, 30. As I'm sure you can imagine, union is going to union these two together. So to union these two together, I create a new variable name here. It's called set3, and I'm going to do set1 dot union. And that's going to take the two sets and union them together, which you'll see here in a second. So I'll go ahead and print set3. And as you can see, they were both put together like so. So the union will take both sets just like this, and it will combine them together into a new set where all the elements are together, and there's obviously no duplicates between the two, right? So it takes all of this and all of these, right? And then anything that they share in common as well, get all put together. Okay, so that is the union operation. It's essentially like the same as adding tuples together, except for sets. Cool, cool. All right, so there's your union operation. Now, the next one that you'll have is the intersection. So intersection is a nice little one, which is going to grab only the elements that they have in common, right? Let's go ahead and look at the intersect. So let's say we have a 10 here, and we have 2, 3. If I go ahead and do the keyword intersect, intersection, I go ahead and do of set2. Let's go ahead and print this. The only element that they both had in common was 10. So this is going to grab 10 from both of them, and we'll put that in. Now, you can also use the update method as well here. And let's say I have 101 here. This will do essentially, oh, excuse me. So this would be, excuse me, for update, you would do it this way. You wouldn't set it to a variable like that. You would do it like this. So it's pretty similar to the union method, except for update, you don't have to add any like third variable or anything like that. It's just going to extend. So like this. And there you go. So the union and the update method essentially like work the same, except for the union method, you need to create that variable, where update, you don't need to create that variable. However, they both come here and they both have these. Now let's say you do this, but let's say that there are duplicate elements inside the sets here. So let's say I have 10, 20, 30, and let's say I have another string here of 2 and 3. Notice it's going to get rid of the duplicate elements. So we're just going to get 3 once, 2 once, 10, 20, 30, right? And this is the same thing for the union as well. If I did a third set here, so I had set 3, set that equal here. This will also get rid of the duplicate elements as well, which is what makes these operations different than, let's say, like a tuple. So that's something to keep in mind, but both of these essentially like work in the same way. Now, another thing you can do is you can also not only do just the intersect, like so, and set that to a new set, but you can also do the intersection update. So let's say I have set 1 here, and I do intersection update of another set. Let's say set 2. I'm going to go ahead and now print set 1. It works pretty much the exact same way, where it gets the intersection and then prints that to the console window. So the intersection will return a new set, and then the intersection update will allow you to take one set and overwrite its data with another set and essentially replace the variable data with a new set. So instead of having to create a new variable name here, you can just do this for the update method of intersect, and then the regular intersection creates an entirely different set, right? Now, a cool one is the symmetric difference. So let's go back to our little diagram here, and look at the various things that we've done. So let's say we have two sets, right? And we have these three areas. We have what's contained in this, what they have in common, and then what's contained in this. The union takes this, this, and this and puts them together into one set. The intersection only took this. It only took what they had in common and put it into one set. Now, the next one we're going to look at is the symmetric difference. The symmetric difference is not going to grab the intersection. It's going to grab everything except for the intersection. So it's going to look a lot like this, where you get these elements of set 1 and then these elements of set 2, but it will not include anything that they have in common. And you have a symmetric difference and then a symmetric difference update, and they essentially do the same thing. So let's go ahead here. We have two sets here that have some elements in common. The intersection yielded only the elements in common. The union included all the elements here, and what they had in common once. And then you have the symmetric difference. So let's go ahead and do symmetric difference update. Again, this makes it so you don't have to create a new variable here and assign it. This is just going to update set 1 based on this. And watch what it's going to return here. Just 20 and 30 because 2, 3, and 10 are here. So it didn't include anything here. But let's say I had 4 and 7. It would include that now into this. Just like so. So that's the symmetric difference. It just gets all the unique elements of a set. So set 1 only had these two things. These other ones were a part of this set already. And then this set only had these two things. These were are part of this one. So it excludes the intersection. It gets rid of this middle part here. It gets rid of like this zone right here. It excludes that zone. So yeah, that is a lot of sets. There's some couple other things that you can do. For example, you can check to see whether something's a subset of something else. So a subset would be like this, for example. So in this case, set 1 is a subset of set 2 because all the elements of set 1 are contained in set 2. So if I did print is set 1 or set 1 a subset, and you would do is subset of set 2, you would get the boolean true. And then obviously if I added like, I don't know, 100, then you make sure 100 what is in there, and then you would get false. So that's the idea of a subset. You can also check to see whether they are disjointed. So disjointed or is disjoint checks to see whether there's an intersection. So in this case, there is, so it's is disjoint. In this case, there is elements they have in common here, which are string 2, string 3, and the int 10. So this will return true because they're, set 1 to set 2. Get rid of this. Oh, my bad. Did that. That's why. So we have set 2. So is disjoint, So is disjoint checks to see whether it is disjointed. In this case, because they had an intersection, I'm getting false because they did have an intersection. And if they don't have an intersection, meaning that they have no intersection, they have no common elements like this, I will get true because there are no common elements. So is disjoint checks to see whether they have any elements in common. If they don't, then it is disjoint, so you get true. And if they do have things in common, then you get false because it's not disjointed. And the last thing I think we didn't cover, small method here, but you can also copy a set by doing copy. And that does exactly what you think it would. It just copies the set. And I'm just going to print the same thing here as set 1. And yeah, I think that's pretty much all the methods that you can perform with sets and pretty much a big giant overview of sets. So if you stuck around for the entire video, you're a trooper, and you should really be informed about sets. They are a very dynamic data type. That's why I spent a lot of time talking about them. And I really hope this video helped. If you have any questions, comments, or concerns, please leave them in the comments, and I will see you all in the next one.